Hey dosto, welcome to my YouTube channel. So today we are enhancing our knowledge about the subject mechanics of solid. So I prepared the notes to understand the topic better. So without wasting any time, let's get started. Let's start. Mechanics of solid, also called as strength of material, mechanics of material, and mechanics of deformable body. So these are the other names of mechanics of solid. Now we all know about solid and we all know about rigid solid. In the first year of engineering, we studied about the concept of rigid solid. We are going to see here once again. By applying load, there is no deformation takes place. Now, what is the meaning of this word deformation? This, it simply means change in shape. When we apply load on a particular body, then there is no change in shape. Such type of solid is known as rigid solid, and such type of body is known as non-deformable body. Now, the second type of body is deformable body, which deforms by applying load. So in mechanics of solid, we are going to more focus on deformable bodies. Now, why we are studying this subject? The most important question is not how we are going to study or what topics are we are going to study. The most important question is why we are studying the subject. So there are three reasons behind it. The number one reason is, being an engineer, we should know about how much deformation will take place by applying load. So when we apply load, how much deformation will take place, we should know about that. The second reason is, we will come across designs. We got to make sure that design should be the number one, safe, durable, that is active time period should high, and economical. We have to check all the 3 points, that is safe, durable, and economical, to get our design sanction. So the third reason is, we will try to apply load on different solid, different objects, and see how much deformation will take place both along the direction of load and perpendicular to the direction of load. Now, what are loads? It simply means forces acting on a body. You can see I drawn a cube, and in that cube I drawn 3 forces, the number 1 force, the number 2nd, and the number 3rd. These forces acting on this cube, and such forces is known as loads. So there are 5 types of load, and we are going to see one by one. So the number 1 type of load is surface load. Let's see what is it. You can see I drawn a cube over here, and in that cube I take a surface, and I drawn the surface over here, and these are the forces or loads acting on it. These are the loads acting collectively on it. Such type of loads is known as surface load. In the definition, forces acting on an area or surface collectively called as surface load, and it is denoted by F. So the number 2nd type of load is linearly distributed load. Let's see. So in this diagram, in this cube, I take a linear surface, and I drawn this surface over here, and these are the forces or loads acting linearly. These are the loads acting linearly on the linear surface. Such type of force or loads is known as linearly distributed load. This bunch of force is linearly distributed load, and mostly we are going to see in beams. So the third type of load is point load or concentrated load. We just saw in the previous types of load that the area was quite big, or the area was either surface or either linear surface. But in the case of point load or concentrated load, the area is very small. There is only one force can act on it. Such type of loads is known as point load or concentrated load. So the fourth type of load is axial load. Let's see what is it. You can see I drawn a cube over here, and in that cube I take two centers of the cube, and I join them through a line, and it will become an axis. You can see a particular type of force is acting on the axis of the cube. Such type of load is known as axial load, which is acting on the axis. So the number fifth type of load is eccentric load. Let's see what is it. You can see this part of the cube I drawn here to understand the next type of load. And a particular type of force is acting away from the center, not on the center, certain distance away from the center. Let's see the definition. If the load is certain distance away from the center is acting but not on the center, such type of load is known as eccentric load. Now, the distance between the center and this load, this distance is known as eccentricity. Such type of load is known as eccentric load, and the distance between the center and the load is known as eccentricity.